Morning. So this is going to be another short video. I'm going through a period of laziness at the moment, or lack of motivation. I'm not sure, so I have to force myself. But it's just a quick experiment to look at the algorithm and the mechanism to use these switches controlled by an Arduino so that I can put a voltage on the sense and the sense ground, like in either orientation, so the positive here or negative here and vice versa, and then use the Arduino program so that in the end with the Arduino I can measure the voltage here. So that's one of the tasks that the cable tester will do. So if I can do this, so we've got A, B, C, D. So the switches A, B, C, D, which the inputs, sorry, they control. So if you turn on, so I'm going to leave these switches on all the time, WO and W1. So they're already on. And so if you turn on A and D, so that means it goes in here, and then so the positive is at the top, and then B is off and C is off, but D is on. So the ground, so if this is ground, then it goes to the ground. So that means that if switches A and D are on, then a positive voltage here can get measured by the ADC here. So, and then alternately, if switches B and C are on, as well as WO and W1, then yeah, that means that I was also, sorry, I've got a diode. This diode here, it should have been here. So I've got a diode plugged into here at the moment. Oh, that's not correct. Let me just, I can't erase easily. Yes, there's a diode. There's a diode in this line. That's bridged, because that's not what you want. You want it after. So if B and C are on, then a positive voltage here will go to the top of that, and a negative is connected through B to the bottom of that. So so they've got, for the Arduino, this is D2, D3, D4, D5, and then that's connected to A7 analog input, and then so the ground of the Arduino is connected there. So, and the power to the whole board is from the Arduino, but the input voltage is completely isolated from with the power supply. So otherwise, if the ground was the same reference, then there'd be a case where you'd connect ground to here and then positive to here and then ground, and that would be a short sort of, well, it wouldn't be quite a short, but it would be a problem, I think, if you turn D on. So I'll just show that working. So at the moment, the program, which I'll show in a second, it's turning those switches and trying to figure out if it can measure what's measuring a voltage and finding zero. So what the ADC is looking at is going to be here. So if I then switch on, it's just 4.4 volts. If I switch on, so now, so the positive is actually on the positive. So that means, and if you look, A and D switches, they've been turned on. That's what those two LEDs there mean. And the multimeter is measuring 1.24 volts. So now, if I take this off, it'll go. So and the LEDs are pulsating again because it's just swapping the switches around to try to find. So if I turn around, so now we're expecting B and C to come on. Yeah. Okay. And the multimeter. So it's essentially it switches over so that you're always measuring a positive voltage at the output, the ADC output. So the multimeter again is about 1.24 volts. So that works. So I'm still, I'm really bad at organizing myself. So I think I had a design for the other part, which is this has got to also use the same switches or the same a modified version of the same circuit so that you can actually apply a voltage onto those lines, which is on the other end, so that it either looks or transmits. Well, that'll be the final version to actually do cable testing. So each end the intention is to connect each end via Wi-Fi, and then they go through this sequence of applying. One end applies voltage and the other end looks for it on all of the wires, and then it should be able to figure out which wire goes to which other wire. As I said, I think I made a design for that, but then I lost it. So I went out yesterday and bought some folders so that hopefully I can keep all of the documentation together and not have that problem. Okay, so I'll just show what's happening with the Arduino. So if I start this up, something happens. Nothing's happening. Why? It's very slow. Okay. I have a feeling that starting up the new version of the IDE, yep. It's true. It wants to update. Okay. Okay. Yeah, yesterday I must have been using the old version of the IDE. I don't want you to do that. I'm not a fan of this thing. Okay, so this is the program. It's pretty simple, so that it's just controlling. So showed before. So to turn a switch on, and put a 0 on the output. So when the top input is of the sense is once if we're trying to see if the top of the sense is positive, then we turn on A and D and off B and C, and vice versa. And it just sits in a loop and spins, and it also will tell me the voltage. It's not very accurate, I found, compared to the multimeter. So then if I look at the monitor, are we working? It's got to be 115, I hope, and I can't click. So now if I take this wire off, as it can be seen, no connection. Okay, so 1392, that's, yeah, it's rough. I found that the analog to digital conversion needs to be a bit of a delay. It's a bit slow, unless it's the switches, but I think it's the converters. It takes a while. So the voltmeter says 1.2 volts. The analog to digital converter says 1.4 roughly. So if I swap this around, so it's gone back to no connection, should have, and then positive. Yeah, so that works. So I think at least that my concept of using these switches to do the job is probably going to work. My understanding of them seems pretty reliable, and I can control them. Anyway, that's a short video. It's good to make these because it forces me to actually do something. Because yeah, as I said, I go through periods of laziness and nothing gets done. Anyway, thanks for watching.